Nowadays, the usage of lasers in data networks, so for example with transceivers, is common practice. And that makes laser safety a very important topic. Now, of course, we all know we shouldn't look directly into the laser, but did you know that a laser with a safe and low classification can very quickly become a higher and more critical classification by using it in conjunction with a technology that is widely used in data networks? If you want to find out more, stick around and we'll check it out. Before we get to that, let's first have a look at some theory. The first question is, what is a laser? And the answer to that question is the name itself, because laser actually is an acronym and it stands for Light Amplification by Stimulated Emission of Radiation. In other words, the optical signal coming out of a laser has a very high energy density because it is amplified. Now, the other very important thing to know about a laser is that the optical signals, so the rays coming out of a laser, are extremely parallel. And those two things combined actually make lasers so dangerous for our eyes. Let me explain. So in the schematic you will see a drawing of our eye, and then here on the left-hand side we've got a divergent light source. So in other words, let's take a normal light bulb, for example. And the rays of light of that divergent light source are actually going in various different directions. And the result is that actually only a very small portion of that light actually will enter our eye, and then the eye does what it's supposed to do. The lens then focuses the remaining light onto the retina so that we can see the picture. Now, if we look at that exact same setup, but in this case we're actually using a laser, then you will very quickly see that because the rays of light are so parallel, far more light will actually pass through into our eye and then are focused onto the retina. And of course, keep in mind that the energy density of these rays is much higher, and those two things combined then can cause permanent damage to the retina. Now, the other thing is that it's not in that visible spectrum, because that visible spectrum is here, and the wavelengths that we're using in the optical networks is here in this infrared area. So we can't even see the lasers. Now, the lasers themselves, we've got different classifications. And basically, you can say that classes 1 and 2 are relatively safe unless being used in conjunction with optical instruments. However, the classes 3 and 4, well, they are the classes that really then can very easily leave permanent damage to the retina, and class 4 even to the skin itself. Now, the good thing is that the transceivers that we're using in our optical networks actually have class 1 lasers. But I mentioned at the beginning that by using it in conjunction with other equipment, then we can actually reach higher classifications. And in this case, I'm actually not talking about the optical amplifiers, so EDFAs or SOAs, which obviously also do that. No, in this case, I'm actually talking about passive optical multiplexers. Because what a passive optical multiplexer does, it takes multiple laser signals and combines them onto a single output. And that combination of multiple class 1 lasers actually then can elevate the outgoing signal to a higher classification. So in other words, it doesn't matter, although it's only class 1, the lasers that we're using, it is always important to take the necessary safety measures and of course never ever look directly into a laser light source, or even worse, into the output of an optical multiplexer or amplifier. Please keep in mind, this video isn't replacing a laser safety training. It is only providing an insight into a very small part of the topic of laser safety. So, I hope you enjoyed this video and that you learned something today. If so, please leave a comment. Of course, follow our channel so that you get your regular dose of brain snack, and see you in one of the next videos. Bye bye!